This is about implicit differentiation. If a function can be expressed as fx equals to the function of x, this is called the explicit method, explicit function. Like this quadratic function, like this radical functions. But sometimes we were given this kind of function, this kind of equation. This one, you won't be able to get your y value, okay? This one, you might be able to get your y value, but this one, you don't get your y value easily. For those kind of situation, we have to use the implicit method. So let's work out this one together. We have to pay attention to something called power rule and also chain rule for the first question, okay? You can go ahead, do it, and then we can check the answer together, okay? Right. If you finish, let's compare, okay? You finish? Did you finish?
Oh, yeah.
Okay, let's check together. The first one over here, we use a power rule. As we know, x to the power n derivative equals to n times x to the power n minus 1. This one over here, y to the power n derivative is n times y to the power n minus 1 times. We cannot forget about the chain rule. We have to put dy over dx, okay? If it's x, dx over dx is 1, so we don't need to write down. But if it's not x, we have to consider about the chain rule. So this one over here, this is 3y squared times dy over dx plus 2y times dy over dx minus 2x, okay, equals 0. Then we can combine this like term, and we can move this to this side. So that's the answer. Same answer, right?
Yes.
Good. Let's move on to the second one. For the second one, we have to pay attention to the product rule. Yeah, do you get the result?
How did you?
XY derivative?
Yeah.
This y, xy is x times y. This guy derivative, you have to do the x derivative. X derivative is 1 times y plus x times y derivative, which is dy over dx. Yes, remember when we learned the product rule, we said u times v derivative equals to u derivative times v plus u times v derivative, okay? Y derivative is dy over dx. Y derivative means dy over dx. X derivative is dx over dx, which is 1, okay? So that's the reason we have to drill the chain rule, product rule, and also the quotient rule many, many times before we can master it. That makes sense?
Yeah.
Good. Now let's work on the next. When you see this one, you might say, wow, this guy is not nice, okay? Because look at this. It has somebody times somebody. It has also trigonometry inside. So we have to pay attention. We have to make sure we follow the product rule and we also follow the chain rule. If this thing make you feel a little bit confused, you can write this thing like this, okay? You can first write this. Cosine x derivative is negative sine x times you copy down sine y, right?
Yeah.
And then you plus, you copy down cosine x. Then you times sine y derivative. Sine y derivative, you have to use the chain rule. Sine y derivative, first it is cosine y. And then because y is not x, so you have to do y derivative. Y derivative is dy over dx. And then this guy equals to 0. Does this make sense?
Yes.
So now, next one. We can get the dy over dx. Yes, we do cosine x times cosine y times dy over dx equals sine x times sine y. So dy over dx equals now that this makes sense.
Yeah.
Good. Now let's challenge us a little bit. Okay. We are going to do the second derivative, which you did it before. Okay. So based on the implicit method, first get the first order derivative and then get to the second one. Go ahead, please. For doing this kind of question correctly, you have to pay attention to the chain rule all the time. So far, did you get your first derivative?
Almost there. Okay.
Okay. Now let's move on to the second derivative. For the second derivative, we can use the implicit method. We can also use the explicit method. So let's set up this into two branches, okay? On the left, we use the implicit method, and we are going to compare the answer. This part is the headache part. Yeah, let's take a look at here, okay? This product derivative, you are going to do the derivative for your left and also for your right. So based on the product rule, this guy derivative, x derivative is 1, y derivative is dy over dx. You have 2 in front. This guy times, you copy down this one. And then plus this package, you copy down times this guy derivative. So as I mentioned in previous classes, d of your first derivative of your first derivative is called your second derivative. Okay? Yes? Yeah, this guy is your second derivative definition. But this guy times this guy is your first derivative square. Your first derivative square has nothing related with your second derivative. They are two different physical meaning, okay?
Mm-hmm.
Which part you finished?
I'm on the second to last line of the
Okay.
first one. Can you go through the second to the last line for the one?
Sure. Let's take a look at here. You do the product rule. This guy. So I take over here, okay? Yeah, I take out this guy and put here. I get 2y plus x times dy over dx. And then I'm going to do the derivative. Oh, sorry, okay. So this guy, I'm using this one. I'm using this one to come to here, okay? So x derivative is 1. 2y derivative is 2 times dy over dx. That's the derivative of this term. And I copy down this. Product rule, this guy derivative times this. Plus I copy down this term. And then I do the derivative here, yeah? Equals to negative y derivative is negative of dy over dx. Then I move this term to the right. So x plus 2y times the second derivative equals to this part. Do you have this stage?
Yeah.
Okay. And I want to combine, I want to take out this factor. They both have a dy over dx, negative dy over dx. So I take a negative dy over dx out. So this term becomes to 1. And then this term, after I take out this negative, this one was left with this parenthesis. Do you have this one correct?
Yes.
Good, that's very good. Next, then I just I take the 2 out. So 1 plus 1, I take the 2 out. This becomes 1 plus dy over dx. I already have the dy over dx in my previous step. So now this is the time for me to plug in dy over dx into here. So dy over dx is negative this term. I put negative, which is positive. So the thing I'm going to put is 2 times y divided by x plus 2y. And then I times this thing, parenthesis, 1 plus dy over dx. That is 1 minus y over x plus 2y. So this is 2y divided by x plus 2y times this guy. You do the common denominator. after you do the common denominator, this top is x plus 2y minus y, which is x plus y. The denominator is x plus 2y. So you become 2 here. And you divide it by your left side. Your left side also have a factor of x plus 2y. So you put x plus 2y in your denominator. This has x plus 2y squared. You divide it by another x plus 2y, you have x plus 2y cubed. So the final solution is 2y times x plus y, parentheses, divided by x plus 2y cubed. Do you have the same answer? Did you get the same answer?
Wait, can you explain the x plus y over x plus 2y again?
This one over here?
Yeah.
This is x plus 2y over x plus 2y, which is 1, minus y over x plus 2y. So this is x plus 2y minus 1, which is x plus y.
Okay.
That makes sense?
Yeah.
Okay. Yeah, you notice that to get the final answer correctly, it's not so that easy, right? So this is using implicit method, right? This is using implicit method. And as you see over here, I want to push you to use the quotient rule, get the second derivative. Give a try, please. Yeah, you want to give a try for this, please. As a quotient rule, this guy derivative is going to be your denominator square on your denominator. And then y derivative times your denominator minus y times the denominator derivative. Okay, yeah, let's give a try for doing this way. If you can do this one, the same result as what we get here, you master the quotient rule perfectly. Give a try, okay? Yeah, I first hide my answer and then let's go through after you finish. For calculus AB, they don't have so high requirement for the students. For calculus BC, you need to be able to do this thing, okay? Quotient rule is the most complicated rule to apply. Look at this. We review the quotient rule one more time. U over V derivative is going to equals to U derivative times V minus U times V derivative divided by V squared. This rule is simple to remember, simple to write down, but not easy to apply, especially for those complicated cases. So easy thing is the denominator. Let's write down the denominator square, which is this. No problem, right? Then we want to do a top one derivative. You don't want to put a minus here together, make you more confused. You leave the negative outside by itself, okay? And then you start to do your top one derivative. Your top one derivative, which is y derivative. Y derivative is dy over dx. Dy over dx times your denominator, which is x plus 2y. And then you minus y times your denominator derivative. Okay, pay attention to here. X plus 2y derivative is 1 plus 2 times dy over dx. Did you get the first step correctly?
Yes.
Good. Don't forget about this negative outside. And then you want to combine some like term. You have a dy over dx. You have a dy over dx. So you want to take out dy over dx. Take out dy over dx. This becomes x plus 2y. Then this is minus 2y. Did you get this step?
Yes.
And then you minus y. Yeah. So this thing, 2y get canceled. So you have a dy over dx times x and then minus y. Please pay attention to here. Dy over dx, we already get it. It's this one. So we want to plug in this package into here. Okay. After you plug this package in here, this becomes to negative y over x plus 2y. Okay. Do you have the same step as what I have here?
Oh.
Which
No.
part did you miss? Did you miss anything? A little bit?
Yeah, kind of.
You miss this negative?
Yeah.
That's a common mistake. Okay, that's a common mistake student could miss. I also miss it at the first time. Then I see something wrong, so I go back to check. Yeah, you can go ahead and run the following procedure. This question is BC level. Okay, yeah, this is BC level. Pay attention. This is all negative. So negative, negative can all be canceled, which is positive. All right. Now, do you get the exactly same answer? Same answer, right?
Oh, I'm still working.
Okay. Yeah, finished. Good. Yeah, how do you feel this question now?
A bit better.
Yeah, it looks so complicated, but actually it's not so that horrible. It is possible, okay? Now let's do the next one. Find the equation of the line tangent to this, okay? You know this is a circle, and you want to find the tangent line of this circle, and on this point, -3 and 4. Yeah. So what we do? At first, I had all the answers. I would like you to give a try, okay? You want to find the tangent line. So you want to first give a try for the derivative. Use the implicit method first, okay? Based on the implicit method, you take the derivative of each term. X squared derivative is 2x. Y squared derivative is 2y times dy over dx equals to 0. And then, because at this point, that means you pass this point, so you can plug in -3 and 4 into this equation, so that you found out your tangent line, the slope is equals to 6/8. Okay, that makes sense? Does this make sense to you?
How did the 6/8 come from?
You have no problem for this part, right?
Yeah.
And you put -3 and 4, -3 and 4 into this equation.
Oh, I didn't realize.
Uh-huh.
I forgot that it was multiplying.
Okay, so this is -6 plus 8, and then dy over dx is 6/8, which is 3/4.
Okay.
And your line, you are going to use the point slope format. The point slope format we learned is y minus y0 equals to the slope times x minus x0. As you see, your y0 is 4, your x0 is -3, minus -3 is +3, okay? That makes sense?
Yes.
Yeah, we can also use this decimals to help us verify our answer. So we can have x squared plus y squared. You can go ahead, type in your own decimals app. Yeah. So this is a square, and this is a circle standard equation. And the next equation is y equals 3/4 times x plus 3. And then you move forward on the right. As you see, this point is -3 and 4. Yes? That makes sense?
Yes.
So before we learn calculus, when we learn pre-cal, at that time, we also learned, teacher also asked us to solve this kind of question before. So let's look at the way we solve this one before learning calculus to see if these two methods support each other, okay? Now for each question, I not only explain you one method, but also ask you to look at other methods to solve and truly understand the question. Look at this. This equation was given. That's a circle, center at 0. And it has a tangent line. Tangent line means you are connecting with the circle by just one point. This is not tangent line. You cross this circle by 2 points. That's the secant line. You touch your circle by 1 point only. This is called tangent line. The tangent point is given by -3 and 4. So if you connect the tangent point with the center of the circle, okay, then this radius is going to be perpendicular to this tangent line. Does that make sense? Yeah. Your radius is going to be perpendicular with your tangent line at the same point. So what's the slope of this line? What's the slope for this line? This point is -3, 4. So your slope is y minus 0 is 4. X minus 0 is -3, right? Correct?
Yes.
You see 2 lines perpendicular. Their slope product is who?
1.
-1, right?
Oh, yeah.
K1. I do want to refresh all those things you learned a long time ago. K1 times K2 is -1. Okay? K1 times K2 equals -1. So K2 equals -4/3. So K1 should equals to 3/4, right?
Yes.
Yes. So your slope is 3/4. And you also pass this -3 and 4. So that means what? Y minus 4. Point slope format. Okay, y minus 4 equals to 3/4 times x plus 3, right?
Yes.
Are they the same answer? Yes.
Yeah.
They should support each other. Okay. Calculus should totally agree with whatever you learned previously. If you get a different answer, that means you probably did something wrong. Okay.
Okay.
Yeah. Let's move on to the next one. Again, I'm going to hide my solution first. I want you to pay attention to this equation. Find the locations where dy/dx is undefined, all 0 in this equation. Okay. So this is conics. This could be a hyperbola or parabola or a circle or ellipse. You don't know the shape. So they ask you, whatever this graph later on when you draw it, they ask you to find the derivative is undefined. This is a place derivative undefined, right? Vertical slope or the horizontal slope. So you're looking for those points. By given this one, I want you to first give a try to see who is this guy. Yeah, this is the time to check your foundation of algebra 2 and the pre-cal. Who is this guy? What kind of factoring you can do based on this equation?
I will copy down this question.
Yeah, please copy down this question. This is a very good question. This is those type of AP question. Okay. Yeah, you found out something?
Factoring.
It's this, right?
Yeah.
This guy can be simplified to this. So that means you either have x squared plus y squared equals to 4, or you have y squared minus x squared equals to 4. Right? Who is this? Wow, that's a circle. Who is this?
That's a circle.
Hyperbola. Hyperbola. Okay, this is a hyperbola. Yeah, if you don't remember, when we learned the x squared over a squared minus y squared over b squared equals to 1. This is a standard equation for hyperbola. Hyperbola, if it's major x on the x, this is this. If the major x is on the y direction, that looks like this, right? Hey, so this is a hyperbola. Yeah, based on this information, yeah, you make this equation, make this another equation, then do the same thing as what you did over here. Apply the implicit method. Go ahead and get the derivative, you know, and make your dy over dx equals to 0. That is this. And then whatever make your denominator equal 0, that's the answer for those undefined. That makes sense? Yeah, go. Give a try. Yeah, do the implicit. You can set up this equals 0. You can set up this equals 0. Okay, you can split this one now.
I found the derivative, but like, how do I do it when it's split up?
Oh, so this is the first step. Okay, this is the first step to make this guy split into a circle and a hyperbola. Yeah, in the y direction. And then next one, we can do this. So let's do this. This is the first step. And then let me move this up. Okay. Next one. When you have x squared plus y squared equals to 4, right? Yeah. So we do the derivative. Derivative of this one is 2x, yeah, plus 2y, and then dy over dx, right? Equals to 0. So we want dy over dx equals to negative x divided by y, right?
Yes.
Yeah. So if x equals to 0, if x equals to 0, then y equals to how much? If x equals 0, y equals to plus or minus 2, right? So 0, 2, or 0, negative 2. This is the places where dy over dx go to 0, right?
Yes.
For what location you have undefined, this is make your y equals 0, right? If y equals 0, then x equals to plus or minus 2. Then you have 2, 0, or negative 2, 0. This is dy over dx, undefined, right?
Yes.
Okay, yeah. And next one, we are going to do the derivative for this guy. So, sorry, at the beginning, I use this method. And later I thought we can do a simple way by using the right one. Then we write down y squared minus x squared equals to 4. And we can do the derivative over here also. So the 2 times y times dy over dx minus 2x equals to 0, right? And then dy over dx equals to positive x over y, right?
Yes.
Okay, so when x equals to 0, y equals to plus or minus 2, right? Yeah, so that means at 0, 2, or 0, negative 2, dy over dx equals to 0, right?
Yes.
And when y equals to 0, when y equals 0, the x squared couldn't be negative 4, right? Yeah, negative x equals to 4. This is impossible, right?
Yeah.
Yeah, so that point doesn't exist. So this gives us the, this gives us the location. This is location. Location on 0, 2, or 0, negative 2. We have 0 derivative. At 2, 0, or negative 2, 0, we have undefined derivative. Does that make sense?
Yeah.
Okay. If we want to verify this with this, okay? So we can draw, if we do here, x squared plus y squared minus 4. You see, I still like to use those things we learned in Algebra 2 and pre-cal, like those graphing to help us understand and verify our answer. This equals 0. You see, they do give us beautiful graph, right? You see here. So look, this graph show us the places you get 0 derivative is on this point. Yeah, at 0, negative 2, 0, positive 2. Yeah, the circle's top and the bottom point. And on the left and the right, this is the places where it has undefined derivative. That makes sense?
Yes.
Okay, so I'm going to also attach this graph for you. Yeah, you see decimals still work, right?
Yeah.
And your graph calculator, TR Inspire, also work. It's going to go with you together, even for your college and graduate school, okay? Yeah, actually, I already have the graph over here.
Oh.
Look, yeah, I didn't see that. Yeah, you can split them writing down these two equations. Or even you just type in this one directly. They are going to give you the same answer, you know? The Desmos, the graph calculator, is smart enough to know that you are going to do the same thing, okay? Yeah, so this guy is really smart. If you type in this one here, they are going to draw the same thing, okay? So this point is the places. This is 0, 2. This is 0, -2. Look at here. This point give you a 0 derivative for the circle and also for the hyperbola. Yes?
Yes.
And this point give you an undefined derivative. This is -2, 0. That's 2, 0. That makes sense?
Yeah.
Good. Okay. Now let's do the last one, okay? Yeah. Let's try this one, okay? Again, I'm going to hide my answer also. Follow the same way. You use the implicit method. A trick I want to mention about over here is I don't like the y in the denominator. It makes my calculation too complicated. What I did is I times the y for each term, okay? Because quotient rule is really not nice, you know, compared to the product rule, right? So if you times y for each term, this makes your calculation easier. That makes sense?
Yes.
Okay. Whenever you see your denominator has some variables, when you want to use the implicit method, I suggest you times the same thing for everybody, okay? Yeah, you do a step over here, it's going to save your time later. You get your answer?
Almost. Okay.
Yeah, let's check. So after you times y, x squared plus x squared equals 9y, right?
Yes.
And yeah, we do the implicit method. We do 2x and then product rule come. This guy derivative is 1 and copy down y, okay? 1 times y plus x copy down times y derivative, right? Equals 9 is a coefficient constant you put in front, and the y derivative is y prime. Sometimes I write down y prime, sometimes I will write down dy over dx. They mean the same thing, okay?
Okay.
Yeah. Next one, I do 2x plus y equals. They both have a y prime, so this is 9 minus x times y prime. That means y prime is going to equals to 2x plus y divided by 9 minus x. So you have this correct, right? So they ask you where the tangent line is horizontal. So you want to make your first derivative equal 0. That's the places where your tangent line is horizontal. So you make your numerator equal 0. So 2x plus y equals 0. Y go to negative 2x. Yeah, but you need to give the point. And you have the equation and you plug in. You plug in here, this is x squared minus x times 2x is 2x squared equals 9y. 9y times negative 2x is negative 18x, right? So this is negative x squared equals to negative 18x. That gives you x equals to 0 or x equals to 18. Does that make sense?
Yes.
When x equals 0, you can plug in. Right? You notice that this type of question, when you get based on your derivative equals 0, you find a y and x relationship, and then you plug in back. You find your x value. Then you plug in back again to find your y value. You are looking for the point location, right? So when your x is 0, 0, 0, wow, that means 9y is 0, so y is 0, right?
Yes.
Okay. When x is 18, when x is 18, you also plug in. So you plug in, this is, you do 18 squared. You do 18 squared plus 18y equals to 9y. That is 18 squared equals to negative of 9 times y. So your y is how much?
36.
Negative 36. That's perfect. So your y equals negative 36. So you have 2 points. These 2 points you get is 0, 0, and 18, negative 36, right? Yeah.
Yes.
This is places that your derivative or your tangent line is horizontal, you know. And then vertical. This one, this is a horizontal. Vertical one is you make your denominator equal 0, right? Yeah, you make your denominator equal 0, so x equals to 9. Then you do 9 squared plus 9 times y equals 9y. Oh, 9y, 9y cancel. You are saying 9 squared equals 0. This is impossible, okay? So you don't really have a vertical line. You don't really have a vertical tangent line. Does that make sense?
Yes.
So again, we like to draw this one. This is something we can draw, all right? Same thing, you can list it in the decimals. You can quickly list the equation. What you list is just type in this equation, x squared over y, and then plus x equals to 9. You see? This is something we draw a long time ago, remember? Yeah. When we do the optimization questions, okay? So this is those kind of curve, and you are looking for the horizontal and undefined. This one don't really have undefined. This one have a horizontal at 0, 0, and 18, negative 36. Okay, that's a 2 point. 0, 0 is a 1. The other one is negative 18, positive 18 and negative 36. Yes, this is on this location horizontal, on this location horizontal tangent line. Does that make sense for you now?
Yes.
Yeah. So I'm going to send you this, and you please also redo. If for example, this question, yeah, you didn't solve fully this question, so you want to go through this by yourself without looking my notes, okay? Yeah, this one, it's an easy one. This one, you want to go ahead do this, make sure you can factor this to that format by yourself, Okay. Yeah. No question for this, right? You can handle this kind of thing, right?
Yeah.
Good. That's very good. And then this one, when you see this, you don't want to do the quotient rule over this. This is make you too complicated. You want to times the y, simple way. Okay. All right. I'm going to upload the stuff now. You have any other question?
No, I don't think so.
All right.